Alrighty, everybody. I just got the okay to start our planetarium show, so I'm going to put away our space trivia questions for now because now we're going to be heading into the unknown. Ooh. And once again, folks, welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself real quick. My name is Christian. I'm going to be your planetarium presenter. And just a heads up, I'm not a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward into the dome before you. That's where the whole show's going to be. I just want to let you know that I'm going to be here. I'm going to be your space pilot. And just to let you know, folks, hey there. Just to let you know, folks, the show that we're about to do right now is by far my favorite show to do here in the Morrison Planetarium. The reason why is because this show is completely live. So you're going to hear my voice for the next 30 minutes. And with this show, we're going to be doing something called Tour of the Universe. Essentially, what that means, we're going to start off pretty close to the Earth and we're going to zoom all the way out to the very edge of the known universe. Hopefully, by the end of the show, you won't have an existential crisis of where we are in space because we are so tiny. Yeah, seriously, we are tiny in space. And before we get started, I got to go over some quick house rules just so that we're all on the same page. We can have a great experience in the planetarium. First off, there's no food or drinks allowed inside. If you manage to bring any snacks or beverages, make sure those are tucked away to the very end of the show. We want to keep this theater nice and clean as long as possible. This also does include no feetsies on the seats because, again, we want to make sure the seats stay nice and clean for all of our future guests coming in. So thank you for that. Also, folks, if you happen to have any 21st century gadgets like cell phones, smartwatches, tablets, anything that produces bright white light, now is the perfect time to turn them off, deactivate them, put them away for the next 30 minutes. These devices produce really bright white light that can be very distracting, not only for yourself, but for the folks sitting behind you. So again, make sure those are tucked away till the very end. And also, folks, the biggest of them all, please wear your mask at all times above your nose while you're here in the planetarium dome. We are in an enclosed space. We're going to be here for 30 minutes, and it looks like there's about 80 to 90 of us here in the planetarium. So again, please wear your mask at all times. Can't stress that enough. And also, folks, if you need to exit the planetarium for any reason, you're more than welcome to do so. All we ask is that you exit at the very top of the planetarium. That's where the exits are going to be before, during, and after the show. So when in doubt, always make your way up the stairs, not down them. And last but not least, folks, this show is very immersive thanks to our 70-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy way to ground yourself. All you got to do is close your eyes, take a few big deep breaths. Your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling through space, at least not more than the usual. Hee hee hee. But otherwise, that's all I have to say. Y'all ready for a cool planetarium show? Alrighty, everybody, sit back, relax, and let's get started. Alrighty, folks. As I mentioned, we're going to be starting off pretty close to home at this really amazing spacecraft that we humans have built and put into orbit around planet Earth. And this is by far the biggest thing we've ever put into orbit around planet Earth. What we're looking at, folks, is something called the International Space Station, or the ISS for short. And it was first started by Russia in 1998. And pretty much Russia sent up the first first module, which is going to be right in the heart of the International Space Station. Since then, many nations across planet Earth have helped out and added modules to it. So it's been adding or getting bigger over the years. So there's been help from many countries all around the world. Pretty much, we want to figure out what happens to things in space. So the International Space Station is a research facility that's orbiting around our planet. So they do all sorts of experiments up here. For example, they want to know what happens to things in space, like what happens when you try to grow plants out here in space. Does it behave the same way as it does when you try to grow plants on planet Earth? Do they act differently when there's less gravity? What happens when you try to drink water? Does it behave the same way? And of course, what happens when you try to start a fire or pretty much ignite a flame? Does it behave the same way when you're closer to planet Earth? So these are some of the different research questions that they want to figure out here out in space. Now, folks, the International Space Station looks quite large here on our planetarium screen, but it's actually not that big. We can see the Earth just below us, and the International Space Station is about the size of an American football field. You can also use the California Academy of Sciences if you went from one garden all the way to the other side to the next garden. So it's about the size of the museum here that we're sitting in right now. And just to let you know, the International Space Station can fit about 6 to 8 astronauts at a given time. There's not a whole lot of leg room. Most of them are going to be hanging out in those modules right over there. And just to let you know, folks, the International Space Station isn't too far away from planet Earth. It's only about 225 miles above the surface of the Earth. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. And not only that, folks, one of my favorite things about the International Space Station is that this thing is going incredibly fast. It's going a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And just to let you know, folks, the International Space Station is as far as we put humans into space nowadays, because traveling out into space gets quite expensive quite rapidly. First off, you got to get yourself a rocket ship or build yourself a rocket ship. And not only that, you have to get your hands on a whole lot of rocket fuel, because you need to get yourself and the rocket and everything off of the planet. So you're going to need a whole lot of rocket fuel. And not only that, you need to account for all the food, the water, all the air you're going to be breathing in space. So the bill starts to get quite costly quite rapidly. But let's leave the International Space Station behind. And now we're going to slowly see the International Space Station pretty much fade away into the outback of Australia. So we're orbiting just above Australia right now. And before we lose sight of it, we do have a nice orbital path so we can keep track of the International Space Station as it slowly disappears. And just to let you know, folks, the space program that we're using here in the planetarium right now is something that you can technically go home and download if you want to fly through space, just like how I'm doing right now. This space program that I'm using is called OpenSpace. So if you go to any popular search engine on the internet and type in OpenSpace project, you'll be able to download this. But just a heads up, folks, this program is in its beta phase, which means it's not completely finished. We might encounter a few glitches or bugs here and there. If we do, I'll let you know. And just to let you know, also, this program, OpenSpace, uses a whole lot of information. So I wouldn't recommend downloading this if you have an older computer. If you have a gaming computer or a newer one, go for it, give it a try. It takes a whole lot of processing power and also storage. So just keep that in mind if you want to do that. And if that doesn't sound like something you want to do, but you still want to fly through space, there's also another program that you can check out at home. If you go to your favorite search engine and just type in NASA's eyes, just like eyeballs, you'll be able to fly through space just like this. You won't have to download anything. It's just on the internet. So if you want to fly through space, you could do that here as well, or at home. But let's leave planet Earth, folks, and we're going to be making our way over to our nearest natural neighbor to us in space, the moon. Now, just to let you know, folks, we humans have been to the moon before, but that was quite a while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon, conduct science, and of course, they got to play golf here as well. But just to let you know, folks, NASA has a new space mission in the works that's going to be sending humans back to the moon again, because the last time we went, that was a little more than 50 years ago. This new space mission that NASA is working on is called Artemis. Pretty much in the next year or two, NASA is going to be sending humans to the moon, and pretty much they're going to be setting up lunar colonies. They're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, their long-term goal is to pretty much send humans to Mars. So before we send humans all the way deep into our solar system, a really far journey away from us, or great lengths away, it's so much easier for us to figure out how we humans are going to live out here in space. So instead of, again, sending them all the way to Mars, we have the moon, which is not too far away compared to Mars. So they're going to be setting up different lunar colonies on the moon. And then what's also really neat is that they're also going to be having an international space station of sort orbiting around the moon as well. This space station is going to be called Lunar Gateway. So if anything was to go wrong while they're up here at the moon, they can get in their ship and launch off the moon and head back to Lunar Gateway, where they can be safe in orbit around the moon. So again, look out for any news about Artemis coming in the next couple of years. Cross my fingers. Hopefully everything goes according to plan. And folks, when we look at the moon here on Earth, it almost feels like you can reach out your arms and touch the moon. It feels so close to us. But just to let you know, the moon's about 240,000 miles away from us here on Earth. 240,000 miles away, that's 250,000 miles. Now, some of the adults in this room may own a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop, going 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And folks, from here on out, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities. Astronomers instead use a more convenient measurement known as light speed. Now, light travels at a mind boggling speed of 187,000 miles per second. That's about 300,000 kilometers per second. So, while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so ever since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But let's leave our moon behind. So, everybody say bye bye, moon. We'll see you later. And now, folks, we're going to be heading into a much greater realm of our solar system because now we're going to watch the moon and the Earth in their orbits as they slowly recede. In fact, let me add the trails of our planets so we can keep an eye on it. Because out here in space, you start to lose objects quite easily. And just to let you know, folks, on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to computer models like OpenSpace showing us the most accurate images and information available to us. And as we start to zoom away, we're now going to be able to see the nearest star to us, the sun. And here comes the sun. Do, 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 do. There it is. Now, folks, the sun is, again, incredibly far away from us. The sun's about 93 million miles away. 93 million miles away, well, that's not that far away in terms of light speed. Now, in order for light to cross that distance, it only takes it about 8.5 minutes to travel that 93 million miles away. But really quickly, I just want to show you something really cool. So we are the third rock from the sun. So at the very top right, that's us right there. So 93 million miles away, that sunlight, the last sunlight pretty much got emitted, and it's going to travel that 93 million miles or 8.5 minutes. So what's really neat is that let's say the sun was to turn off all of a sudden, we humans wouldn't know about it here on Earth for that 8.5 minutes. So the sun would turn off, that last bit would reach us, and then all of a sudden the daytime would be nighttime. Now, this is a really cool concept to grasp because this also works for really far away objects. For example, let's say we're looking at a star that's 60 light years away from us. Well, it's taken that last bit of light from that star to travel 60 years to finally get to us. So as we're looking at that star, 60 years further away from us, it's kind of like looking back in time in a sense, which is pretty cool. So when you're looking out into very far away objects in space, it's like looking back in time. But now that we have a nice bird's eye view of our solar system, really quickly, I'm going to go over the planets in our system. And right in the heart of our system is, of course, our star, the sun. The closest planet to the sun is going to be Mercury. Then we have Venus and Earth. That's us. And then we also have Mars. These are the rocky terrestrial planets. These are places we can actually land a spacecraft if we wanted to. And then beyond Mars, we have this really cool thing called the main asteroid belt. And this is what it would look like if we were to highlight all the asteroids in our asteroid belt. Give it a second. There's quite a few of them. There they are. Now, one of my favorite facts is that the asteroid belt was discovered by a European society known as the Celestial Police in the early 1800s. The Celestial Police sounds like something out of Doctor Who. But beyond the asteroid belt, we also have the really big planets. We have the gas giants. We've got Jupiter and Saturn, the Jovians. And then beyond them, we have our icy giants. We have the funny one, Uranus and Neptune. And then we can also add everybody's favorite and lovable dwarf planet, Pluto. And here's the orbit of Pluto for you folks, just appeared on screen. A lot of people tend to ask me, hey, Christian, why did Pluto get kicked out of the Planet Club? I learned about it in school. I think Pluto's still a planet. Why did it get demoted to a dwarf planet? I love Pluto. Well, you see, folks, astronomers got really good about learning about the outer parts of our solar system, specifically the region beyond the orbit of Neptune. And this area over here, scientists have labeled as the Kuiper Belts. And you're probably wondering to yourself, what's the Kuiper Belts? I've never heard of that before. Well, the Kuiper Belt's going to be all this stuff. There we go. So the Kuiper Belt's essentially a second asteroid belt. Since it's much further away from our sun, They're mostly icy asteroids and icy comets in this location, but pretty much astronomers were able to find more than 400 objects out here in the Kuiper Belt region. So we couldn't call all this stuff planets. There was just way too many of them. So all the astronomers across planet Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet. And one of the criteria that you need to be is that you need to be so big and so massive that you push all the other stuff out of your orbital path. Unfortunately for Pluto, it's not the biggest thing in its orbital path. And not only that, it also does a dance, orbits around its own moon. So this is one of the reasons why Pluto got kicked out of the Planet Club and is now considered a dwarf planet. But don't worry, there's quite a few dwarf planets out here in the Kuiper Belt region. We've got Makemake, Eris, and Haumea, just to name a couple. And of course, we have Ceres in our main asteroid belt, much closer to us. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And really quickly, I'm going to show y'all some of the spacecrafts that we sent out in the 1970s to explore our solar system and leave it behind. And here they are. There we go. So on screen, folks, we have the orbital paths the paths of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2. And all of these objects are the farthest traveling human man-made objects, all traveling fast enough to escape the sun's gravity and leave our solar system behind. Now, just to let you know, in order for light to travel all the way to the orbit of Pluto, it's going to take about 5 light hours, so a good distance away. But let's leave our solar system behind, folks, because now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us over 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. So right in the middle, that's our solar system. And as we continue zooming out, we're going to see our nearest star system to us. And if my calculations are correct, I think we just flew through our nearest star system. So we're right here in the middle. To the right is the Alpha Centauri system. Now, again, 4 years at the speed of light just to reach the next one to us. Now, to give you an idea of how long it would take for us humans to travel in a rocket ship, it's going to take about 8,000 years. Ooh, that is a very, very long road trip. But folks, we're going to stop and consider whether humanity has made its presence known beyond our solar system, because now we're going to be heading into something called the radiosphere. So again, we are now inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. Now, this first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. Now, humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they travel at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year, so is anybody out there listening? And folks, I'm going to be adding some markers onto the screen. These markers represent some of the many thousands of stars astronomers have discovered over the last 22 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far to date, we found more than 4,000 exoplanets just in our nearby vicinity to us. So we are finding exoplanets left and right. In fact, as I tilt over, we can see a whole bunch of exoplanets just in that region. That's where our space telescopes focus, and we found a whole bunch of exoplanets just on the other side of this radiosphere. I want to try to spin us around so we can see it on the left-hand side. And that 4,000 number of exoplanets is going to be growing as the years continue, because we have new space telescopes where their whole purpose is to find as many exoplanets as possible. So that 4,000 number is going to be going up as the years continue. Now, to figure out if any of these planets are suitable for life as we know it here on Earth, well, our technology is not yet able to answer that question, but new generations of astronomical instruments are devoted for that search. So once they get built, we'll be able to learn a little bit more about that. But the important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there that's able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we're inside the radiosphere. Let's say this star system on the very far left. We find an alien civilization 60 light years away from us. Let's say this one over here. We shoot them a text message, hi. Takes 60 years to get to them. They listen in, answer back. Another 60 years to reply. That is a 120-year conversation in the making. Whew, and I can barely wait for a text message from my friend. But of course, folks, planetary systems beyond our radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, folks, I want to put away our exoplanet markers, and I want to leave our radiosphere up on screen. As huge as humanity's electromagnetic footprint is, it is nothing compared to the Milky Way Galaxy. So let's see if you can keep your eyes on that radiosphere. Alrighty, folks, we are now looking down on our Milky Way Galaxy. Is anybody able to see their house from here? Just kidding. Now, again, we are looking down on our Milky Way Galaxy, and our Milky Way is incredibly large, folks. If we wanted to cross our galaxy from one side to the other, it's going to take about 130,000 light years to cross our Milky Way Galaxy. Incredibly large. And not only that, our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within our small neighborhood, within this vast star city, is any indication, there could be potentially billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way Galaxy, I do want to stress the shape of it. When we look at our Milky Way Galaxy from a sideways perspective, you notice that we live in a flat spiral disk. So just keep this in mind. This is going to come important later on the show. When scientists and astronomers want to learn about the universe, it's so much more easier for them to point their telescopes and equipment galactically north and galactically south, instead of looking through the plane of the Milky Way, which has gases, debris, stars, planets that obscures their view of the universe. So again, astronomers and scientists like to look up through the galaxy or down. So just keep that in mind. That'll come important later on in the show. But folks, the Milky Way Galaxy is only one of many hundreds of billions of galaxies that comprise our known universe. In this giant leap, we're now going to see a view where each point of light no longer represents a star. It now represents the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. Now, we live in a local galaxy group, which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, which is only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And folks, as we start continuing expanding out, you're going to start to notice that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large galaxy clusters, or they like to avoid each other with voids. So we can see a nice galaxy cluster on the bottom left of our screen. We can also see some voids on the right side of our screen. So just keep that in mind. Galaxies like to hang out in large groups or avoid each other. And folks, just to let you know, the picture that we're now looking at represents the closest 30,000 galaxies to us in space, over 300 million light years across. We got to give thanks to a pretty amazing astronomer by the name of Dr. Brent Tolley, who worked at the University of Hawaii, who compiled this amazing representation with the works of dozens of other astronomers working over decades of time. So big shout out to Brent Tolley. Thank you for creating this amazing galactic map we're able to fly through right now. But folks, now we have automated systems that are mapping even the most distant galaxies. We're now about to see the large-scale structure of the universe. And remember, folks, every single point of light that you're seeing is not a star. That's an individual galaxy. Whew, I feel small. And also, just to let you know, folks, the universe is not shaped like a butterfly or a bow tie. Remember when I just mentioned that we live in a flat spiral disk of our Milky Way Galaxy? Well, if we were to line up our Milky Way Galaxy, it would line up something like this. It would just line up right in the middle. So this is the plane of our Milky Way Galaxy. So astronomers and scientists point their telescopes galactically north and galactically south instead of looking through that plane of the Milky Way. Now, astronomers still want to make sure that there was galaxies through the plane of our Milky Way, which we can see a nice purple survey there. So we found some galaxies through all that gas and debris. But you're going to notice that we can't find galaxies as far as we like because of all that stuff that obscures our view. So as technology gets better, hopefully we'll be able to look through the plane of our Milky Way and we'll be able to map all the galaxies in these dark regions that haven't been filled in yet. So it's only a matter of time. But let's continue out. And now, folks, we're going to be heading so far out, we're going to be looking at these objects known as the quasars. And here they are. So the quasars are going to be these orange dots at the very edge of the large scale structure of our universe. So these are all quasars. And quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So now we're going to press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we are about to approach the very edge of the known universe. And here we are. So, folks, we are now looking at something called the cosmic microwave background image, or the CMB image for short. Now, all evidence indicates that the universe that we live in is about 13.8 billion years old. And this is data compiled by Planck and other radio telescopes. And the picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo either, but a temperature density image, where the light echoes of the Big Bang are color coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely, extremely tiny. They vary no more than 1 part per 100,000. But eventually, they gave rise to that large scale structure of the universe, that clumping and clustering of galaxies everywhere. Figuring out how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But, folks, we've traveled as far back as the law of physics can physically allow us, so we only have one direction left to go, which is back home. And before we make our return trip back to planet Earth, I've got to ask y'all to prepare yourself because this could possibly be the worst free falling dream ever. Hee hee hee. But let's find a nice entry point through all these quasars and galaxies. And let's make our return trip back home, folks. So, folks, we are crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. Sometimes all you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way back into our radiosphere, and it looks like we're walking fast, faces past, and we're homebound. Dun-dun-dun-dun-dun-dun. And now we're heading back into our solar system, passing those spacecrafts that we sent out in the 1970s, passing the orbit of Pluto, and we're making our way to the third rock from the sun, our home world, the only place humans have ever called home. And folks, as we make our final approach back to planet Earth, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with me today. I hope you did enjoy it. But that's it for today, y'all. Thank you for stopping by.